Math and physics are two very similar subjects, and they're quite intertwined with each other, especially from the physics point of view. A physics major is going to be required to take a bunch of math courses along their program because you need to know the maths to be able to do the physics in the first place. A lot of physics is trying to describe a physical system by formulating it in terms of math or equations and then seeing how that system evolves or what changes to the theoretical model are going to result in, I guess, changes in the physical world. On the other hand, if you're a math major, you probably aren't required to take physics courses in your program, but a lot of math majors probably are interested in at least some aspects of the physical world. So I think what is actually important is that there are two main flavors of physics. One is experimental and the other is theoretical physics. And they can be actually quite different, but they usually come hand in hand. So in a physics department at a university, most of the work has probably got an experimental bend to it, but it's going to be rare to find a project that is purely experimental without at least developing some theory behind what's going on. Some aspects of this purely theoretical physics would actually happen in the math department. So that's going to include ideas you might have heard of, like string theory. String theory is actually purely mathematical in a sense because it doesn't yield results that you could test in a physical experiment. It's only things you could essentially test with equations. Similar ideas, I think, would be aspects of general relativity that deal with differential geometry, so essentially shapes and how they're changing and how we can use them to describe the universe. So whilst these ideas do have applications to physics and explaining the world around us, actually you'd find this work going on in math departments. So if you kind of know that you want to end up in that purely theoretical side of things, I'd probably say you'd be better off doing a math major than a physics one. The physics major, I think, sets you up really well to do more of an experimental kind of work. Maybe like a lot of your courses will be lab work, writing lab reports, dealing with things like thermodynamics, electronics, electromagnetism and mechanics, so that you can actually build and test theories in the physical world and see how things are working. So I think that's sort of the difference between the majors, but it's hard to know when you sign up to uni which one you'd want to end up working in more. So I actually did a double major in both mathematics and physics. And look, I wouldn't say that I would necessarily recommend that. I actually don't think your majors matter too much per se. In the end, I think they're just a line on your degree, but they don't define what you have to do in the future. So I'm doing an experimental project now. I probably don't use much of the math I learned at all, but I'm still glad that I did it. And the reason I did the double major wasn't planned. It was just that I kept taking courses that I was interested in, and it sort of ended up that by the end of my degree I had taken enough courses to fulfill the requirements of both these majors separately. But in order to do that, I did overpoint almost every semester, and overpointing means taking more than the full-time load of courses. So in my case that was taking 5 courses every semester instead of 4. Now, there's no reason you would overpoint. It doesn't give you any benefit or advantage other than that you can do it if you want to, and I just wanted to do it because when I overpointed, I was taking courses that just seemed really interesting to me. So whether it was taking an extra course in group theory or computer science or the history of mathematics, all these courses I just saw and I didn't want to pass them up. I thought it would be a shame if I didn't learn about that topic. I just really wanted to learn them, and I knew the best way for me to learn them was to take them as an extra course. Sure, you could have taught yourself some of that knowledge, but I felt the best way for me to actually get involved in them was to just take them as an extra course. I guess for me, I found it doable to do 5 courses every semester, but if you're already like stressed or have a lot of like extra commitments or work or something, then it's probably not a good idea to take more courses than you need to. Yeah, I think it was just something that I did it at the time, and I'm glad I did it because I did learn a lot by taking those extra courses, and I don't know, it was cool to get the double major, but it's probably not necessary by any means. I think no matter if you major in physics or in math, they're so similar really that you just need to sell to your future supervisor or to your future employer the skills that you gained, and just, I don't know, in terms of if you want to go into grad school and do a PhD afterwards and you're worried, should you do physics or maths? It doesn't matter, like you just need to, like, it doesn't matter what major you do, you could do anything, you could do philosophy even. You just need to be able to convince that supervisor to take you on as a student, and to do that, I think who you are as a person and your interest in learning and doing research is way more important than whatever line is on your degree of like what majors you had. So I don't know, keep that in mind. I hope it helps. Thanks for watching.